Yo, what's up, guys? We're back. Episode 55. Um, oh, been a little bit of a long morning, but it's okay. Gonna try and tackle a few problems today. Oh yeah, let's check out our Pokemon start of the day. So, there are 55. We got a Golduck. It's crazy. Golduck goes crazy. Ba-da-dum, ba-da-dum, ba-da-dum. That's the Golduck sound. Ba-da-dum. Nice. What a video. Let's check out our quick problem of the day really quick. See what we got today. Most profitable path in a tree. Seems like a good problem. Let me think. Yeah, let's do this problem. I mean, we're probably gonna do a binary tree problem anyway, so I might as well take a look at it. A lot of words. I hate it when there's that many words. What is this, a graph problem? Do I want to do a graph problem? Probably not. I know I probably could do this problem. I mean, a graph problem is kind of the same thing, but I'm going to skip the graph problem for now. I want to move on to that a little later. Got to take it slowly and try and master each topic, so let's take a look at our list. Yeah. You know what I'm thinking today? Maybe we can, how we probably do, let's try and do maybe 2 hash map, 2 binary tree. I think that's probably good stuff for today. Try and get it through these ones. Kind of want to move on to these ones here, some sorting and searching. I mean, these aren't many, I haven't really done them, but this is going to be a tough one. I know. Find binary search very tough, but it's alright. We'll do it either way. We'll start off with our hash map problems just to kind of get in the groove a little bit, I think. This one has a lot of words. I don't know if I want to keep doing that problem, but yeah, you know, I don't know. Which one should we do? How about we check out this problem for starters? Given a binary array, nums, return the maximum length of a continuous subarray with an equal number of zeros and ones. For some reason my forehead hurts a little bit. I don't know why. Okay, so I'm thinking here, well, longest continuous subarray. Return the maximum length of a continuous subarray with an equal number of zeros and ones. This seems a lot easier than having a 48.9% acceptance rate. I don't think, see, I'm thinking the most simple solution here is just iterating over this using a for loop and counting numbers as zeros and ones. I don't know. I feel like these aren't the best test cases either, to be honest. Let's take a look at the discussion. That's the best set of examples. There you go. Count ones and zeros as prefix sums. think I'm gonna do this problem and go quickly take a shower and then come back. I think I need to wash my hair. I feel like my hair is greasy as hell. Like, You have 2 as. See, I don't know. I'm thinking in this problem here, well, I don't think it's as easy as, I mean, obviously not. I don't think it's as easy as you think it is. Like, you know, having a hash map and counting the numbers, like, that's not going to work. With this case, I don't really know what a continuous array is exactly. Like, is that they're balanced the whole way through? Continuous. And I have to go to the bathroom as well. This is not good. Let's ask for a hint, because I... Okay, so a hint is that we treat 0 as -1. For num in range length nums, if num is equal to then num is equal to -1. What is that noise? Let's create a dictionary. Alright, then we do, well, I mean, if the number is not 0, then it's got to be 1. So then if it's 1, then we just, we would we be able to curve that? Okay. Let's do our current, this cur. Alright, so then we do, well, cur plus or equal num, and then we update it in our MyDig. Is equal to 1 else cur plus or equal to num. And the same thing here, right? Then we want to return res equal to 0. Do well if max res is greater than 0. Value is greater than max res. Max res value. Current value. Let's see what this does. There's an edge case here. How do I go? Okay, I'm comparing it to a string, so that's stupid for one. each running sum. This is an interesting way to do this. I mean, so we're starting 0, -1. Store the first occurrence of each running sum. Running sum, the max res, I and num, and enumerate nums. Get rid of this. So they do a little bit of list comprehension cur plus or equal to 1 if num is equal to 0 else 1. If cur in my dictionary max res equal to max res I minus go dictionary cur else minus go dictionary cur is equal to 1. Then we return max res. Sorry, return max res. That's meant to be -1. Whoops. Oops. Okay. So iterating through I and num, cur plus equal 1 if num is 0 else 1. If cur is in my dictionary, max res is equal to max res. Do I minus my dictionary cur. Okay. Check out some of these solutions. What did they do here? They did. Interesting, same thing. Okay, all right. I'll be back. I am going to take a shower and then we'll do some more problems. All right, we're back. Back after the nice shower. Feel much better. But yeah, let's take a look at another problem. Let's take a look at the longest palindrome. Well, the longest palindrome that can be built is DCC ACCD, which will make this 7. Given a string which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, AA is not considered a palindrome. That reads the same forward and backwards. How is that a palindrome? Oh. Wait, what? How is this a palindrome here? Okay, this is a palindrome. DCC, ACC, D. Okay. Oh, we have to rearrange it. Do we? Oh. That can be built with those letters. Ah. That's an interesting problem. Surprised this is an easy problem, to be honest. How can we go about this? Well, what do we need for a palindrome? We need more. We would need an even number, right? So maybe it's all. We would need an even number, I think. DCC, there was CC, CC, DDA. We will need. How can we do this? We don't actually need to build the palindromes. There's obviously some sort of math involved to build this palindrome, but I'm not sure kind of what it is. Is it, well, I know we have to loop through this in a hash map and get all the values and add it to a hash map, right? But how we use those hash map values to find out what the biggest palindrome is. I guess let's do that first. So let's do, well, let's do our my dictionary is equal to counter. Yes. Let's print my dictionary. Okay. I think there's a lot of edge cases in this. If the length of S is equal to 1, then let's just return 1. I think this would be an edge case. Create the counter to hold values. How can we loop through this here? For key value in items, if items is greater, well, I guess if it's even, then we can add it, right? So for key value, my dictionary.items, you can check, well, if value percent 2 equal to 0, then I guess, well, we need to create our res here. Create our res to return. key value might equal to 2, then let's just append res plus or equal to value. Else if value we can add one. We can add only one. We'll be able to add multiple. So let's return this. Let's see what this gives us. Return res. Let's see. Right, so we get 6 or 7, but maybe what if we return? This is kind of cheating. Res plus 1. To add all the evens plus 1 odd, because you can only ever add 1 odd. I doubt this will submit, but okay, that's what I thought. Okay, yeah, that's what I thought. That would not submit. Also, if value %2 does not equal 0, let's use some sort of flag and let's create some sort of flag, like let's do like flag is equal to false and flag is equal to false, then we can do a res plus or equal to, ooh, well, what if it's 3? There's that too, because it could be 3, it could be 5, 7, 9, blah blah blah. Well, let's do this test case only for a singular val, right? Only for a singular one. Okay, alright, so then we do, oh, I guess if value is equal to 1, and flag is equal to false, and res plus are equal to value, and then flag is equal to true. Okay, then we have another else if, well, also if value does not equal 0, so it's odd. Oh, if it's 3, what do we do if it's 3? Then we add, well, value does not equal 0, then we do, well, value dot res plus or equal to value minus 1 to make it even. And then we will return our res. This might pass. I don't know. Let's see. Probably missing some sort of other edge case. Damn. There's so many edge cases in this, dude. If there is only one key, if the length my dictionary is equal to 1, then just return, how do we index the first value in the hash map? We return my dic 0 I'm not sure really how to index the first value in a hash map. I'm honestly not sure. Let's double check. Will this index first value in dictionary? Python. Okay. So we can't index like that. Let's just return the sum of minus dictionary.values. Man, this shit has a lot of edge cases, bro. Like, oh my god. Again, there's no way this accepts, like. How? Counter A5 V4. Oh, fuck. Yes, bro, if there's a length of 2 as well, equal to 1, or length y dictionary. Bro, no wonder why this acceptance rate is so low. So many edge cases, bro. Oh my god. Jesus, dude. Okay. There's something here, bro. I need help, man. Bro, there's so many edge cases, bro. Okay. We have our flag, we have our counter. Alright. Let's get rid of this. Rid of this. Okay. Key value in my dictionary items. If value percent 2 is equal to 0, we return it. Else if we do odds, right? So we would do, well, else res plus or equal to value minus 1, and then we flag down dav odd, right? Okay. If the length of, sorry, if res percent, I guess, yeah, well, flag is equal to true, we can return res plus 1. If res is odd. Yeah, let's submit this. Nice. There we go. That was definitely an interesting problem. Like, I mean, look at this, dude. Like, so many edge cases, man. All right, let's jump to another problem. Let's jump to some binary trees. Yeah, so exciting, binary trees, man. Fire. Smallest string starting from leaf, find largest value. Well, bro, I guess we're doing this one. Let's check it out. Given the root of binary tree where each node has a value range 0 to 25 representing the letters A to Z. Turn the lexicographically small string that starts at a leaf of this tree and ends at the root. As a reminder, any short prefix out of a string is lexicographically small. For example, AB is lexicographically smaller than ABA. The leaf of a node is a node that has no children. We return ABC. Well, I guess here we can kind of think about this, I guess, using DFS, right? I mean, we would just reverse at the end, like, I think the best way to do this is we reverse at the end. So we start at the root, we find all our options, right? And then we reverse at the end. Reverse our string at the end. So, okay, they give us these. So A, B, and this is D. Yeah, okay. 1 to 25. Interesting. Okay. So I guess so either we could do the conversions using a hash map, so like the 0, 1, 3, 4, 3, you know, convert them all individually into what their value is, or we could use the ASCII like formula thing, which I have no idea what it is on the top of my head. I don't know. I guess we'll see. So first of all, we want to pass in our node, and then we want to keep track of our current string, right? We probably want to have a res here, right? What I'm thinking here is, you know, we create this, we pass in, well, DFS, pass in our node, and I guess we can just do like a current string, right? Then we can just, I guess we'll do the return later, right? But we're gonna return something like that. I guess let's just make a note here to fix this. Okay. So inside here, we're gonna need our base case. So, well, when are we gonna append? So I guess we're gonna append when if node.right and node.left if not node.right and not node.left, then we can, well, return here. So we return, what will we return here? We would return, but we would append our string. There's not append
we want to cast this into an integer. So we would append our code here, but pass it as an integer. Here, well, every single time we're going to want to we can do here our recursive case, and here we can do, well, if no dot left, then we want to pass in our DFS function, DFS, pass in our no dot left, and then append cur plus or equal to no dot val string. We cast this into a string. And if, well, no dot right, we want to pass in our DFS function. Full no dot right, plus or equal to the string of no dot val. I guess we want to fix that there. We need a double parenthesis here. I guess outside of this function, we would want to do, well, after you call the DFS, we're gonna, I guess, figure out what to return. Figure out return, right? So, well, I guess we'll figure out our return. So, what are we gonna return here? Well, we want to find. As we can find our min val here, so let's declare like a min val here. Oh shit, man. Let's declare like a min val or something. Min val is equal to 0, and then we want to do, well, for. Then we want to do, well, min val is equal to min res. Or we find our min val and then we reverse it. Return reversed, I guess, min val. I think that should work. Maybe. I mean, there's probably some issue here, but let's see. Invalid syntax. What the hell did I do wrong? Valid syntax. TFS no dot left curve. I don't understand. Bro, I don't know. Invalid syntax. I don't know what the syntax issue is. What's the syntax issue? Code plus string, what? Oh, whoops. I meant to pass root here. So I meant to pass. Oh man, we didn't. Okay. So we did the right thing. Okay, well, if it's a leaf node, guess we forgot to check. Well, if not node, then we just return. if it's a leaf node, we have to make our ASCII calculation. Curves, you can how do they do this? Man, this is ord a plus node.val plus cur. Check if it's a leaf node. Get rid of this, we just put cur here. That was a better way to do it. Do it per value. You get rid of this here. But here we still, well, we just return minute res. We don't need a reverse anymore. Okay. Nice problem. Cool problem. Cool stuff. Yeah. Let's take a look at the iterative solution here. So I'm gonna keep this here. Oh, let's keep that. Let's do a little bit of an iterative solution now. Get rid of all this. Okay. Start off by creating a stack. We pass in our root. Our stack is not empty. I guess maybe we want to do root and cur. Does that work? This is going to be an infinite loop. Let's put this up here really quick. We will comment this out. Is this the right syntax? So that's the thing. Cur is not defined. Oh, whoops. You want to put in a little bit of an empty. Oh my gosh, dude. An empty string of some sort. Okay. Okay, nice. Wait, bro. Okay. Okay.
file stack, we want to do, well, we want to pop our node, and our cur is equal to stack.pop. Okay, now here we want to do, well, passing this. Alright, what a plus node.val plus cur. Yeah, so we do that. Want to do, so we do, well, we want to check node.left, stack.append node.left, and cur if node.right, stack.append node.left, cur. For this, we want to check, well, is it a leaf? So if not node.left and not node.right, then we want to just what are we doing here? We want to append to res, so yes, we have a res array here. Do, well, res.append cur, right? Then we want to break here, continue. And I guess we'll need somehow, I think here we need to return, well, return the min of res. We're stuck in an infinite while. Why are we stuck in an infinite while? I am not sure. Network error. Is there something wrong with my internet? I don't know. No shot. Are you serious? Okay. Well, I got internet. Has Leetcode gone down? Yeah. Well, that's a little frustrating. Maybe someone DDoS gateway. Sorry. DDoS Leetcode. Well, okay. I guess we'll be back. I'm gonna pause the video and then I'll come back when this is done. Probably make some food. What's up? We're back. Just refresh the page. Had a little bit of a little fruit ball snack. Yeah. Let's finish what we were doing. So, remember here we were checking, well, check left and right node. Let's actually just run this and see where we're at, because I'm not really too sure. Takes 2 arguments. We forgot our double parenthesis here.
none type. Rec has no attribute val. Check if null. If not node, continue. It's an empty sequence. I think we're actually no. What am I missing here, bro?
Was it that? I don't know. You know, to be honest, min arg is an empty sequence. So assume that our res is empty. I'm not sure what I'm kind of doing wrong here, to be honest. I really don't know. Oh my gosh, dude. Wow, my mistake here. I'm pushing right, left. Maybe try pushing left instead of right. There we go. Nice. Nice. There's our iterative solution. We still want the fastest solution. I wonder what is a backtracking method. DFS. See, I feel like this is so like unreadable, bro. Like, you know, I get they want to do it in like the fewest lines possible or whatever, but like, I don't know. You know, this is hard to read. You know, I can read it, but it's like, it could be way easier. You know, adding some spaces, maybe a few comments, like, way easier to read. Anyway, that's cool. We're gonna keep moving on. So, I'm gonna do one more tree problem. Let's take a look. Count good nodes in binary tree. Cousins in binary tree. Let's do cousins in binary tree. Why not? Given the root of a binary tree with unique values and the values of two different nodes of the tree x, y, return true if nodes corresponding to the values x and y in the tree are cousins, or false otherwise. Two nodes of the binary tree are cousins if they have the same depth with different parents. Note that in a binary tree, the root node is at depth 0, and children of each depth k node are at depth k plus 1. So obviously, we can kind of tell here that this is probably a BFS problem here. Which is good, because I only want to do an iterative solution, so that is good. Now let's import our function here. So from collections, now I remember it, import DQ. DQ. Let's run that, make sure it works. We have an exception rate of 60%. Is this right? Collections import DQ. Is this how you import, bruh? Is this how you import? From collections import DQ. Okay. I'm gonna put it right here inside the class. I don't know. Kind of looks kind of weird actually. I don't know. We'll just put it here. Who cares? Anyway. There's a few things that we need to do. Well, we need to I think we'll create our queue. So Q is equal to DQ. I think that's how we would create it, I hope. We need our level, right? I forget what you just put in the root here. So I guess while Q has something in it, well, okay. I guess what we want to loop through all the values. So for value in Q, Q.pop left. What do we want to do here? We want to check, well, how do we want to do this? This is an easy problem. If node.val is equal to x, do like an X flag equal to false, a Y flag is equal to false, right? If no dot val is equal to X, then X flag is equal to true. If no dot val is equal to Y, Y flag is equal to true. Then we can check, well, if no dot val, if X flag and Y flag, then we can just return true. Outside the while loop, we can flag is equal to false, Y flag is equal to false. Then we want to append our values. We want to check our flags, but we also need to append the next value, right? We have to check, well, check node is none. If not node, continue. Check flags. Then after the flags, we want to check, well, add children. So we do, well, q.add node.left. Yes, if node.left. But add node. If node.right, q.add node.right. Alright, we add the children, we make the flag 0, we skip through the while loop, then we just want to return well. Return true if X flag and Y flag, else false. Let's try this. Will this work? Probably not. There's probably some sort of error. Tree node is not iterable. I feel like this is a decent solution. I mean, let's see what errors I got. Let's check, take a look. I think my thought process was solid. Oh, wait, what? What do you mean we need to wrap it? Oh. We need a length variable, okay. Q. Node is equal to q.pop left, that's what I did. Node is equal to x flag is equal to node dot L is equal to y flag is equal to true. If node dot left and node dot right. Add, what is it? Append. I'm not sure why this is returning false. Oh my gosh, dude. Whoops. Just needs to be here. Okay, let's go the way. Handle the sibling check properly. Even though you're checking if both x and y are found at the same level, you're not verifying if they are not siblings, i.e. they have different parents. Oh, okay, yeah. I understand. These are siblings, not cousins. They'd have to be from the same parents, so you can only really do it on... Okay. I understand. Gotta get rid of this. no dot right dot val is equal to y, and no dot right dot val is equal to x. If no dot left, q dot append no dot left. If no dot right, q dot append no dot right. Reset that, return true. Okay, I think this should be good here. Let's take a look. We're expecting a colon here, so rip that colon in there. God, it's nearly 12, man. Jeez. Okay, let's kind of go through this code one more time. So what we did wrong earlier was that we were checking siblings. That's what we were checking, you know, of the same level, you know. And yeah, like that can be correct in a way, like in this case here, but in this case here it was returning true because sorry, not this one, this one here was returning true because we were checking if they were siblings. But to check if they're cousins, to go to this while loop, we check, well, if node is equal to x, x flag is equal to true. If node is equal to y flag is equal to true. Then we check, well, if node dot left and node dot right, so we're checking a node, if node dot left dot val is equal to x and node dot right dot val is equal to y, or node dot right right dot val is equal to y and node x, we return false. Okay, check if they are siblings. Okay. Then we add children, return true. Okay, yeah. There we go. Little mistake there. Oh, man. No. Thought we were done. We are not done. I think maybe return true if x flag and y flag, else false. Could it be even the return statement? Sibling check. Twice. Oh, okay. Node dot left of val is equal to x. Node dot right of val is equal to y. Node dot left. This is meant to be node dot left. Whoops. Submit. Nope. What is it then? No.right.val is equal to x, or no.left.val is equal to x. No.right.val is equal to y. What are we doing wrong here? Val is equal to y. No.right.val is equal to x. I don't know why this is not working. Logic around the x and y flags. Is it the return condition? That's what I thought it was originally. I feel like this is the same thing that I'm doing, bro. Like, what is going on here? Like, I have to check at the end of the while? Okay. Oh, at the end of the for that level. Okay, if x flag and y flag, we return true. Otherwise, we get through all this, we return false. Okay, I think that could be the issue, maybe. There we go. Okay. Let's take a look at some solutions. Oh, man, my back. BFS and DFS solutions. I thought that was a tough, easy problem, man. What do they do here? Okay, all right. We're gonna call it there for the day. Appreciate you guys watching, and I will see you tomorrow.